Hi guys, this is Mr. Allen, and I'm doing a little supplementary video since I'm not here on Friday. There's a couple of funerals going on with the family, so that's why I'm missing Friday. I'm making this video on Tuesday. I'm going to post a video for the lesson 2.5 that I've made in the past, but this is a video I'm making this week to kind of make sure that everything on the notes that you're given is accurate. So I'm not going to do everything. I'm just going to go over some of the answers and a couple of examples of implicit differentiation. So for number one, just to let you guys know, the final answer for this one, we're trying to find the equation of the tangent line is going to be y minus 16 equals 96, and then the quantity x minus 3. For number two, the final answer is y minus 2 equals the second root of 3 divided by 2, and then x minus square root of 3. So these are your slopes of your tangent lines right here that you would find by finding what y prime is using the chain rule. Okay? So now what I'm going to do is I'm going to go ahead and skip ahead I'm going to do two examples, example 2 and example 3. I'm not going to do example number 1 because example 1, all the work is already laid out for you, and you can see that in another video. So there you go. So there's example 1. I'm going to focus on example 2. So we're trying to find the derivative of this equation that's got x's and y's in it using implicit differentiation. So what we're going to do is we're going to do the derivative of everything on both sides with respect to x. In other words, so we've got this y cubed plus y squared minus 5y minus x squared and the negative 4 over here. So we're just going to go piece by piece. So the derivative of y cubed, well, that's going to be 3y squared, but then we have to multiply it by the derivative of y. Because y is not in terms of x, we have to do implicit differentiation or the chain rule. So then the derivative of y squared, well, that's going to be 2y times the derivative of y, or dy dx. The derivative of 5y, well, that's going to be 5 dy dx. Now here, when I do the derivative of x squared with respect to x, well, it's already with respect to x, so it's just minus 2x. And of course, the derivative of a constant is 0. So now what we want to do is we want to just get this x squared, or this 2x term, over to the right-hand side. So that's no problem. I'll just move it over there. That will make it positive. Everything else over here has a common factor of dy dx. And that's good. That's what we want, because now what I can do is I can pull that dy over dx factor out and leave the 2x over on the right. Everything that's left now is this 3y squared, this 2y, and this minus 5. And now last but not least, we're trying to find dy over dx, so all I got to do is divide everything in the parentheses here to the right. So dy over dx is equal to 2x divided by 3y squared plus 2y minus 5. This is the derivative of this implicitly written equation. We could use it to find the slopes of the tangent lines or calculate the instantaneous rate of change. So in the next example, this will be the final one that I'm going to do, we're going to do the same thing. The reason I'm doing this one, though, is a couple. Number one, I want to point out that here we're going to have to do the product rule. So notice how that says x squared y. So we're going to have to do the product rule. And remember, that's my little cheat code there to remember the product rule. The other reason I'm doing this one is we're going to have to do one additional step. Okay? So what we're going to do is, again, we're going to do the derivative with respect to x of the left side of the equation and the right side of the equation. On the left, we've got 2x cubed minus x squared, minus x squared y plus y cubed. And on the right, we've got 1. So now we're just going to go term by term. So since this is in terms of x and I'm doing my derivative with respect to x, that's no problem. It's just 6x squared. Now here's where I got to be very careful. I'm going to do the product rule. and I'm going to be really careful. And I'm just going to go ahead. I'm going to put the negative out in the front. And I'm just going to basically be doing the derivative of x squared y. Remember, I'm doing that whole 1d2 plus 2d1. So the 1 is the x squared, the 2 is the y. So 1d2 is going to be x squared dy dx plus, now I got to do 2d1. Well, 2 is y, and then the derivative of 2x is, the derivative of x squared is 2x. So this is the derivative of this stuff right here. All right, now, next step, I got to do the derivative of y cubed. So that's going to be 3y squared, but don't forget the dy dx. And of course, the right-hand side, the derivative of a constant is 0. Now I need to make sure that I go ahead and distribute this negative. Also, I'm going to go ahead and, I'm just going to go ahead and do that now. So 6x squared minus x squared dy dx minus 2xy. I'm just going to go ahead and rearrange those into alphabetical order. Plus 3y squared dy dx equals 0. The non-dy dx terms, I'm going to move to the right. I'm going to rearrange the positive terms first. So I'm going to put this last term first, this term here second. Notice that they both have dy dx. And all the non-dy dx terms, I'm going to move to the right. So this is going to be adding, so that's going to be positive. This is going to be minus. And now I'm going to factor out that dy dx again. I'm just going to leave that there. So we're going to have 3y squared minus x squared. The right-hand side, I'm not going to do anything to that. And so now I just got to divide over. My final answer here is going to be dy dx. This is the derivative. It's going to be 2xy minus 6x squared over 3y squared minus x squared. So there's my derivative with respect to x. But this question isn't asking me just for the derivative. It's asking me for the slope of the graph at this point. So now what I'm going to do is over here, I'm actually going to use this derivative to get that slope. So to do that, I'm just going to evaluate dy dx at the point 1/2, 1. In other words, I'm going to do 2 times whatever x is times whatever y is minus 6 times whatever x is squared. Should have maybe picked a different color there. Sorry about that. And then on the bottom, I'm going to do 3 times whatever y is squared minus whatever x is squared. I'm going to go ahead and kind of differentiate this equation from what I've done so far here by kind of drawing this. Okay? And I'm just going to plug in those numbers. So x is 1/2. So wherever there's an x, I'm going to put 1/2, 1/2, 1/2. And wherever there's a y, I'm going to put in a 1. So that's going to be a 1. That's going to be a 1. And we go ahead and work this out, and you will find that the answer here, I believe, is negative 2/11. So the slope, which is the slope, of dy dx evaluated at 1/2, 1 is negative 2/11. And so when we look at this last slide here, this is the actual graph of the curve, this curve. And then if we look at the point 1/2, here's 1/2, and here's the y value of 1, and I draw the tangent line here. So let's see if I can draw the tangent line here. Here's my tangent line. Guess what the slope of that tangent line is? Oops. It's negative 2/11. Negative 2/11. So there you go. I know that took a little bit of time, but I wanted to give you a couple of examples here just so that you don't feel like I left you hanging. Still took me a good 9 minutes.